For centuries, humanity gazed at the night sky, wondering about our place in the universe. The stars, planets, and sun all seemed to revolve around us, making Earth appear as the center of everything. This belief, known as geocentrism, shaped ancient astronomy and philosophy, but as time passed, new observations and ideas began to challenge this worldview. Today, we'll explore the dramatic shift from the geocentric model to the heliocentric model, a transformation that forever changed our understanding of the cosmos. Centrism is the ancient belief that Earth is the center of the universe. According to this model, all celestial bodies, including the sun, moon, planets, and stars, move in circular paths around our planet. This idea was deeply rooted in the teachings of philosophers like Aristotle and Ptolemy. It made sense to early observers as the sun appeared to rise and set each day, and the stars seemed to rotate around us. For centuries, geocentrism was widely accepted and formed the foundation of Western astronomy. Aristotle, one of the most influential ancient philosophers, strongly supported the geocentric model. He believed that Earth was stationary and at the center of the universe, with everything else moving in perfect circles around it. His ideas were based on observations and philosophical reasoning, and they became deeply embedded in both scientific and religious thought. Aristotle's authority helped cement the geocentric view for centuries, making it difficult for alternative ideas to gain traction. Building on Aristotle's ideas, the astronomer Claudius Ptolemy developed a detailed geocentric system in the 2nd century CE. His model used complex mechanisms called epicycles to explain the apparent backward motion of planets. Ptolemy's work, known as the Almagest, became the standard reference for astronomers for over 1,000 years. It provided a mathematical framework that matched observations, even if it was complicated and sometimes inaccurate. Geocentric model was not just a scientific idea, it was also closely tied to religious beliefs. Many saw Earth's central position as evidence of humanity's special place in creation. The Christian Church in particular supported geocentrism, integrating it into its teachings. This connection between science and religion made the geocentric model even more resistant to change, as challenging it meant questioning both scientific and spiritual authority. Despite its widespread acceptance, the geocentric model struggled to explain certain astronomical phenomena. For example, the retrograde motion of planets, where they appear to move backward in the sky, required increasingly complex explanations. As astronomers made more precise observations, the limitations of the geocentric system became harder to ignore. These challenges set the stage for a revolutionary new idea. The early 16th century, a Polish astronomer named Nicolaus Copernicus proposed a bold alternative, the heliocentric model. In this system, the sun, not Earth, was at the center of the universe, with planets, including Earth, orbiting around it. Copernicus's ideas were radical and challenged centuries of established thought. His work on the revolutions of the heavenly spheres laid the foundation for a new era in astronomy. Heliocentrism is the astronomical model that places the sun at the center of the universe, with Earth and other planets orbiting around it. This idea was revolutionary because it directly contradicted the long-held geocentric view. Copernicus's model simplified the explanation of planetary motions and eliminated the need for complex epicycles. It marked a turning point in our understanding of the cosmos. Copernicus was motivated by a desire to create a simpler and more elegant model of the universe. He believed that placing the sun at the center would better explain the observed motions of the planets. Although his model still used circular orbits, it provided a more coherent framework for understanding the heavens. Copernicus's work was published in 1543, just before his death, and slowly began to influence other astronomers. Heliocentric model was met with skepticism and resistance. Many astronomers and religious leaders were reluctant to abandon the familiar geocentric system. The idea that Earth was not the center of the universe was unsettling and challenged deeply held beliefs. However, a small but growing group of thinkers began to explore Copernicus's ideas, setting the stage for further discoveries. Tycho Brahe, a Danish astronomer, made some of the most precise astronomical observations of his time. Although he did not fully accept the heliocentric model, his detailed data on planetary positions provided crucial evidence. Tycho proposed a compromise system, but his measurements would later help others confirm the sun-centered universe. Johannes Kepler, building on Tycho Brahe's data, discovered that planets move in elliptical orbits around the sun, not perfect circles. Kepler's 3 laws of planetary motion provided strong mathematical support for the heliocentric model. His work explained planetary motions more accurately than ever before and marked a major breakthrough in astronomy. In the early 17th century, Galileo Galilei used a telescope to observe the heavens. He discovered moons orbiting Jupiter and phases of Venus, both of which supported the heliocentric model. Galileo's observations provided direct evidence that not everything revolved around Earth, further undermining the geocentric view. Galileo's support for heliocentrism brought him into conflict with the Catholic Church, which still upheld the geocentric model. He was tried by the Inquisition and forced to recant his views. Despite this, Galileo's work continued to inspire others and spread the heliocentric idea throughout Europe. Isaac Newton's laws of motion and universal gravitation provided the final piece of the puzzle. Newton showed that the same physical laws applied both on Earth and in the heavens. His work explained why planets orbit the sun and unified the heliocentric model with a powerful theory of gravity. The shift from geocentrism to heliocentrism was a key part of the scientific revolution. This period saw dramatic changes in how people understood the natural world. Observation, experimentation, and mathematical reasoning became the foundations of modern science, replacing ancient authority and tradition. The acceptance of heliocentrism had profound effects on philosophy and human self-understanding. No longer at the center of the universe, humanity had to rethink its place in the cosmos. This shift encouraged a more humble and questioning approach to knowledge, paving the way for new discoveries. Although the geocentric model was eventually replaced, its legacy remains. It reminds us how powerful ideas can shape our view of the world, even in the face of new evidence. The story of geocentrism is a testament to the importance of questioning assumptions and seeking better explanations. Today, we know that our Sun is just one of billions in the Milky Way galaxy, and our galaxy is one among countless others in the universe. The heliocentric model was a crucial step in this journey of discovery, opening our eyes to the vastness and complexity of the cosmos. Astronomical models are more than just diagrams, they shape how we think about our place in the universe. The transition from geocentrism to heliocentrism shows how changing models can revolutionize science and society. It's a reminder that our understanding of the world is always evolving. The story of heliocentrism highlights the importance of careful observation and open-mindedness. Astronomers who questioned the status quo and looked closely at the sky made discoveries that changed history. Their work reminds us to stay curious and keep exploring. Major shifts in scientific thinking often face resistance. The move from geocentrism to heliocentrism was no exception. People are naturally attached to familiar ideas, and it takes time and evidence to change minds. This story illustrates the challenges and rewards of scientific progress. Technological advances like the invention of the telescope played a crucial role in the acceptance of heliocentrism. New tools allowed astronomers to gather evidence that was impossible to obtain before. This pattern continues today as technology drives new discoveries in every field. The spread of the heliocentric model depended on education and communication. Books, lectures, and debates helped new ideas reach a wider audience. Over time, as more people learned about the evidence, the new model gained acceptance and became the foundation for modern astronomy. The transition from geocentrism to heliocentrism is a classic example of a paradigm shift, a fundamental change in the basic concepts and practices of science. Such shifts are rare but have far-reaching effects, transforming not just science but also culture and society. The story of heliocentrism teaches us to remain open to new ideas and evidence. It reminds us that progress often requires challenging old assumptions and embracing change. These lessons are just as relevant today as they were centuries ago. Heliocentrism was not the final word in astronomy. Later discoveries revealed that the Sun itself is not the center of the universe, but just one star among many. Our understanding of the cosmos continues to evolve, with each generation building on the work of those who came before. The debate between geocentrism and heliocentrism is part of a larger human journey to understand our place in the universe. It's a story of curiosity, creativity, and the courage to question the unknown. This journey continues today as we explore new frontiers in science and space. As our knowledge grows, so does our sense of wonder. The shift from geocentrism to heliocentrism reminds us that the universe is full of surprises. Who knows what new discoveries await us as we continue to look up and ask questions about the cosmos. In summary, the transition from geocentrism to heliocentrism was a pivotal moment in the history of science. It changed not only our understanding of the universe but also how we see ourselves. The courage to question, observe, and innovate continues to drive human progress. As we reflect on this journey, we're reminded that the search for knowledge is never-ending.